ethanol is the guy who will be my nucleophile in this reaction. Not a silver, not a nitrate, ethanol. I have about 2 milliliters added to 6 test tubes of that silver nitrate, ethanol, and I'm going to add drop-wise of my different substances, right? My first one is benzyl chloride. Benzyl chloride is the benzene ring with the carbon and the bromine. Not a bromine directly attached, but the carbon away. So I am adding it. Whoever is timing it first, well, this one you don't really have to, I think. See. All right, put the timer on, and let's see how long it'll take. Who's timing benzyl chloride? All right.
Oh, yeah.
Carly? All right. Next one is allylic chloride. Oh, hold on a second. Something is happening. I see precipitate. Do you guys see a precipitate? It's not supposed to be blue, but I guess there's something in there that makes it blue. No? Bad idea? Yeah. You see on the contrast of the dark, you see the cloudiness? That's my precipitate. What time is it?
36 seconds.
36 seconds. That's a benzyl chloride, 36 seconds. You'll later will have to match based on the actual names in your lab manual, but for now you can just write down benzyl chloride, 36 seconds. The second one I'm working with is allylic chloride. 1, 2, not even. I don't think you really have to time this one because it's already precipitated. So the reaction for allylic is immediate. The moment I put the drop in, it precipitated as it was falling down. So that's how strong allylic are for SN1 reactions. My third one is tert-butyl chloride, tertiary. My predictions are that it should be fast. 1, 2, and yes it is. Look how strong of the precipitate I have. That's very, very awesome. So tertiary works very well in the SN1 reactions. Even slightly better than allylic. Look at the precipitate intensity, right? Allylic was very quick, but tertiary gave me a better precipitate. Now I'm doing secondary. 1, 2, 3, and this one you'll have to time. Whoever wants to time this one, thank you, because it'll take a while. That's a secondary. I'm moving on to primary. Who wants to time primary? Because this one will be long. Thank you. Alright, so I added to the primary. And you see not many changes happening, right? I added, but it's still as clear as it was before because it will take time. And lastly is chlorobenzene. Chlorobenzene, you don't even have to time because we'll see by the end of the class if anything happened with it. So that's my SN1. The only answers we don't have right now is for the secondary, primary, and the chlorobenzene, or phenyl chloride, as you have it on in your lab manual. Moving on to SN2. SN2 is a one-step reaction. I need a strong nucleophile. And in this case, I'm working with sodium iodide, where iodine is my nucleophile and sodium is the stabilizer, because I need something with a positive charge to stabilize my negatively charged iodine. It's very strong, so it will work perfectly with the primaries, secondaries, allylic, and benzylic. But let's see how good it works with primaries. 1, 2, 3. And I see a precipitate forming. Well, I saw it. Guess not. Oh, yep, yellow color. Instant reaction. Primary and butyl. Now I'm doing secondary. For this one, I'll need a timer. Whoever is not doing it yet. Who wants to time this one?
I'll time it.
Thank you. Nothing is happening yet. I'm adding to my tertiary. Who wants to time tertiary? Anybody timer on their phones? Because we all have iPhones with timer settings on them.
You have a timer on your phone?
Thank you. Yep, that's tertiary.
Just someone start doing it.
Yep.
I'll start right now.
Yep. I'm adding my benzyl bromide. Instant reaction. You guys see? My allyl bromide. Instant reaction. Benzylic and allylic. Both of them gave me very nice precipitate. And lastly, bromobenzene. Just like with SN1, I'm not expecting anything from this guy. And I see nothing. But we'll see. We'll keep an eye on this one. Going back here, I see a slight precipitation for my N-butyl, for my primary. Who was doing primary? Yep, what time do you have?
A minute, 36 seconds.
36 seconds. So the primary is 36 seconds.
A minute, 36 seconds.
Minute, 36 seconds. Yes, so 96 seconds. Primary for SN1. Nothing yet for secondary. Weird. Bromobenzene will never give me anything.
Let's see.
No, secondary. It's a little yellow. It's yellow, but it's not cloudy. And the cloudy is what I'm looking for, like here. So let's see. This one is nothing. This one just turned a bit yellow. Secondary. Any questions while we wait?
What's the reason we categorize SN1 and SN2?
The reason is based on the mechanism, right? In SN1 mechanism, because it's a two-step reaction, you depend only on your substrate, the rate. The moment you run out of the drops of your actual chloride, the reaction will stop, which is why they call it SN1, as in you have only one atom that dictates the reaction, and that's your bromide.
So that you do the SN1 for
Carbocations.
So what's the purpose of it?
Oh.
What do you use that SN1?
Oh, that's a pretty much the basic mechanism in organic chemistry. All reactions in organic chemistry follow either SN1 pattern or SN2 pattern for substitution reactions. If you're forming a carbocation somewhere in the process, that's an SN1 reaction. If you are going straight, as in like a leaving group leaves and a nucleophile attacks at the same time, that's SN2 reactions. You will see a lot of SN2 reactions further in the chapters, but every time you saw a carbocation forming, that was SN1 pathway. Those are just typical chemistry pathways. Most of the mechanisms follow either one over the other, depending on what's your substrate. If I have a tertiary alkyl halide, for example, I cannot do SN2. I have to tweak my requirements to make it as an SN1, right? So I need a weaker nucleophile, I need some heat maybe, something that will force the reaction in SN1 direction. Still nothing for the secondary. That is so weird. Let me warm it up a little bit. Okay, slightly. Warming up helps SN1 reaction. That's why you a lot of times will see them accompanied with heat. The harder the reaction, the more heat you need to have. Me holding it like this just gives it about 36 degrees. That's not enough for most of the SN1 reactions. Most of the SN1 reactions actually happen on the stove, where you stir it while it's heating up constantly. But see, by holding it a little bit in my hands, it precipitated, because I gave it a bit of my warmth. But it's not enough for us to... Actually, what is secondary? Who was naming? Yeah.
7 minutes?
7 minutes. Whoa. Yeah.
That's
7 minutes and 5 seconds. Secondary for SN1 was 7 minutes and 5 seconds. so the benzyl didn't change at all. We have an intensified color, so I'm assuming this one did E2 reaction because we didn't form a precipitate, but the color intensified. Intensity of the color depends on the double bonds. If I have more double bonds in my molecule, I have more intensified color. Good example, you guys wear red and purple all the time. That's actually a chemical dye, right? And the dye has a lot of double bonds in it, makes your color very, very intensified. Here, what happened is an E2 reaction. So SN2 reaction didn't even take place because I did not get my precipitate like I did with the first one. I just got an intensified color. So E2 reaction took place. We can say no reaction for tertiary. Secondary and the benzyl. You guys see they're about the same intensity, right? So I think it will leave it for some time. Secondary will react, but I don't know. Who was timing secondary? Yeah, I think so. 36? Really? Oh. Let's say 10 minutes for a secondary. Yes. Secondary SN2, 10 minutes. And for the benzyl, benzene one, chlorobenzene, you can say no reaction took place. That's the end of the experiment. Do you guys have any questions on what we just did?
So bromobenzene is a no reaction.
Bromobenzene is no reaction for both of them, chlorobenzene or bromobenzene. Tertiary did not react with SN2, but it gave me E2, right?
Say again, how do you know it's E2?
Because the color intensified, and intensity of the color depends on the double bonds. More double bonds I have, more intense will be my color. And elimination reactions, you guys know they always give you a product of a double bond. Right? This is how I
Phenyl chloride.
What?
Phenyl chloride.
Phenyl chloride is a chlorobenzene because it's attached directly to the benzene ring. Like your phenols that you guys talked about, right? It's the OH directly attached to the benzene ring. Alright? So if you guys have no more questions, just record the data. You can answer the questions here if you want to, or you're done.